to my YouTube channel. My name's Adrian, for those of you that don't know. And what we're going to go over in this video is a Wear OS application that I made that is actually a timer. So before we start, I'd appreciate it if you guys would like and subscribe, and let's get into this video. Now first, let's take a look at the MainActivity.kt file. This is the main entry point for the app's user interface. It's where we build a screen that shows our timer, connects to the view model, and reacts in real time as the countdown runs. In this file, we also handle buttons that are used for start, pause, and reset, as well as simple overlay to choose custom durations. Up here, as you can see, are the imports. We're importing everything needed for Compose, the Wear OS UI components, and our view model. You'll see imports for layout tools such as column and row, state helpers like Remember Savable, and Wear specific features like time text, position indicator, and scaling lazy column. These are the building blocks for creating a Wear OS friendly interface that automatically adjusts to round or square screens. So here, going down, we have the class and set content. The MainActivity class extends the component activity, and inside the onCreate function, we call set content to describe our entire interface using Compose code. No XML layouts are needed. Wrapping everything in MaterialTheme gives our app consistent colors and typography. Now we get our view model using ViewModel. This gives us access to the same timer view model instance each time the UI recomposes. We then use collectAsState to listen for 3 state flows: the remaining milliseconds, whether the timer is currently running, and the total time that was set. This makes our UI reactive, so it automatically updates whenever these values change. Here, we convert milliseconds into minutes and seconds, and then calculate a progress value for the circular ring. The if total equals 0L, it prevents a divide by 0 error when no duration is set. The result is a clean number between 0 and 1 that drives our progress animation. Next, we create a local state variable called showCustom, which controls whether the custom duration picker is visible. We mark it as Remember Savable so that it won't reset if the screen rotates or the watch briefly goes to sleep. We also create list state for the Wear OS scrolling behavior. That's what powers the round edge scroll indicator. Now we wrap our main content inside a scaffold. This is a Wear OS component that gives us built-in support for things like time text at the top and the position indicator that shows where you are while you are scrolling. Think of it as an outer frame that holds our entire UI. Inside the scaffold, we use a scaling lazy column. This works just like a normal column, but it automatically scales and spaces items to look better on small round screens. The first item in the scaffold is a circular progress indicator. We give it the current progress value. We set the size to 120 dp, and we use white for the active part and a dark gray track behind it. This gives us a clean, simple timer ring that fills up as time passes. Below that, we add a text composable. It shows the formatted minutes and seconds. It's centered on screen, uses a large display font, and has white text for contrast. Every second, this number automatically updates as our view model emits new values. Then we have 2 main buttons, one to start or pause the timer, and another button to reset it. The start button checks whether the timer is running and switches its label between start and pause. Each button simply calls a function inside the view model, so all the logic stays out of the activity. All of this keeps the code organized and easy to test. Next, I added 2 quick preset chips, one for 25 minutes and one for 5. These call set duration minutes on the view model with the chosen value, so users can quickly start a Pomodoro session or a short break with one tap. Finally, there is the custom chip. It toggles our overlay to show custom to be true. This is what lets users choose a custom duration without leaving the main screen. Now here is the overlay itself. Here we check if show return, This is an easy way to skip rendering when the overlay is not visible, which overall helps performance and keep the layout tree smaller. We use another remember savable variable for the current minute count. Starting from the initial minutes passed, the value is clamped between 1 and 120 so that you can't accidentally set it to 0 or something that's way too high. The main structure is a box that fills the whole screen with a transparent black background, giving it a dimmed look behind the card. Inside that, we place a card composable with a dark gray background. Everything inside the card is centered so it feels balanced on the watch. Then we have the minute selector row. It has the minus button, the current minute display, and the plus button. Each time you press minus, it subtracts 1 minute until it reaches the value 1. Each time that you press plus, it adds 1 minute up to the maximum of 120. The middle text shows the number using large typography so that it's easy to read at a glance. Then we have the cancel and OK buttons. Cancel just hides the overlay without saving anything, and OK calls the onConfirm function and passes back the selected minutes to the main screen, which updates the view model and closes the overlay. So that does it for this file. Now we're going to head over and break down the timer ViewModel.kt file. This file is the brain of the app. It owns the timer state, saves it, restores it, and runs the ticking loop. The activity just calls these functions and listens for updates. This view model extends Android view model so that it can receive the application context. I create a timer store instance called store that works as my simple persistence layer so that the timer can survive process death and tile interactions. I keep 3 pieces of state as mutable state flows and expose them as read only. Remaining M's for how much time is left, total M's for the full duration in milliseconds, and running to track whether the timer is active. They all start at 25 minutes by default, except for running that starts with false. I keep a tick job reference so that I can start and stop the coroutine that decrements the timer. If a job is already running, it won't start another one. In the init block, I load persisted data. I then combine 3 flows from the store: remaining, total, and running. Every time any of them change, I update my in-memory state. I also clamp remaining so it never exceeds total. When it becomes false, I can cancel the job. This keeps the app UI and any tile actions perfectly in sync. Toggle running flips the running flag. I update my in-memory running, write it to the store, and then either start ticking or cancel the job. The activity doesn't need to know which one. It just calls this one function. Then we have the reset function. It snaps the timer back to the full duration and pauses it. I set remaining to total, set running to false, cancel the ticker, and persist those values. It's a clean reset with no leftover coroutines. Set duration minutes takes minutes, converts it to milliseconds, sets both total and remaining to that value, pauses the timer, cancels any active ticker, and writes everything to storage. This guarantees the ring and the text start from the new duration without overlapping timers. Start ticking is the ticking loop. If a tick job is already active, it bails out to avoid duplicates. Otherwise, I launch a coroutine in the view model scope. While it's running and there's time left, it delays 1 second, subtracts 1000 milliseconds from remaining, and clamps it at 0, and persists the new remaining value. If it ever hits 0, it flips running to false and persists that too. The loop then exits cleanly. And that's it for this file and for this video. If you guys like the video, please make sure to like and subscribe, and look out for my next part coming out soon. Thank you.